Okay, these are two calculator-intensive problems, and you always know that a calculator is required because the answers are in decimal format. So there's not even an option of doing these by hand. So first we're given a particle position problem. So we have the position when time is greater than 0, and they want to know at the instant when acceleration is 0, what is the velocity of the particle. So we're going to need to first type in our position equation. So let's do that. We'll have 2t minus 7, let's see, 2t minus 7, close paren, I'm putting in the multiplication symbol just in case, times e raised to the t, and hit enter. There it is. So I now need my second derivative because I want to set my second derivative equal to 0 to find the time. Remember, I want the instant the acceleration is 0. So I'm going to differentiate my original expression with respect to t, and I want the second derivative, so I put comma 2, and I hit enter. That's my second derivative. I now need to know the 0 of the second derivative, and I'll do this on the calculator to remind you, but I can see right now it's at t equals 3/2, because e to the t will never be 0, and 2t minus 3 is 0 at 3/2. But let's do the solve button just so we can practice. F2 solve, grab my second derivative, set it equal to 0, comma t to tell it to solve for t. And sure enough, it's at 3/2. So that is the time when acceleration equals 0. Now I need to know the velocity when acceleration equals 0. So the velocity at 3/2. So I'm going to do F3 differentiate, and I need to go up and grab my original position expression, and I'm just doing comma t to tell it to take the first derivative. Okay, so this now is my first derivative equation, and I need to evaluate it at t equals 3/2. So I'm going to do such that, and I'm going to go up and grab t equals 3/2, hit enter, and my answer is negative 2e to the 3/2. This is a case, though, where I need the decimal approximation. So I'm going to go up and grab it, hit enter, green diamond enter gives me the decimal of negative 8.96, and C is my answer. Now, for 13, it's a mean value theorem problem. They're giving you a function on a closed interval, and they're saying when is the instantaneous rate of change equal to the average rate of change. So we basically need to know f of 4 minus f of 1 over 4 minus 1, and it equals f prime of some value c, and we want to know what c is. So what I'm going to do on my calculator is type in 9x squared over x squared plus 2. So I have 9x squared, close parentheses, divided by x squared plus 2. Enter. So there's my expression. Now I want to evaluate this expression when x equals 4. So such that x equals 4, enter. That gives me 8. So coming back over to here, f of 4 equals 8. So now I'm going to need f of 1, which, oops, sorry about that. In my denominator I needed 4 minus 1, which I'll just go ahead and put in as 3. I think I can do f of 1 by hand here. I'll get 9 over 3, which is 3. So basically I need to find out when f prime of x is equal to 5/3. So going back to my equation in my graph, I'm going to differentiate the original equation that I typed in, the 9x squared over x squared plus 2, comma x. So that derivative is given here. I now need to set that equal to 5/3. So we're going to use the solve key. So F2 solve, go up and grab your first derivative expression, set it equal to 5 divided by 3, put in comma x to tell it to solve with respect to x, and hit enter. And it's going to take a minute to think, but when it comes up with the answer, I just have to confirm that my answer is on the interval from 1 to 4, because that's what I'm asked about. The mean value theorem has to be on this closed interval. All right, I got 2.2187 or 0.19, which is not on the interval, so my answer will be 2.2187, 2.218. I'm assuming they're rounding to 2.22 here.